Hello students, welcome back to today's class on perimeter and area. In the last class we have discussed what is a perimeter and how to find perimeter of different figures. In this class we'll continue with perimeter and also we'll learn about area of different shapes, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is the first thing which we have discussed yesterday, right? We discussed about different shapes. That is called rectangle, this is called circle. Right, this is a triangle and this is a square. What is this? This is a rectangle. Right, as we have discussed this one. Rectangle, and this is called a triangle. Three-sided is called triangle. Right, so this is called circle. And for circle, generally we don't say perimeter, we say circumference, which we'll learn ahead. Right, and this, when all the sides are equal, it is called a square. So that's what we have discussed yesterday, right? So let's try to understand more about this one. Perimeter is the distance covered along the boundary, forming a closed figure when you go around the figure once, right? So what are the boundary we're having? That boundary, if we can cover, then we say whatever the distance we have covered, that will be the perimeter. Okay, so you can see here, if we start our journey at this point and travel to this point and then to this point, to this point and to this point, the total path we have traveled, all the way the starting and the ending point are same, the total path we have traveled will become perimeter of the given figure. Okay, let's try to understand more about this one. How many different rectangles with integral measurements can be drawn with perimeter as 32 centimeters? Once again, what is the question? How many different rectangles with integral measurements can be drawn with a perimeter as 32 centimeter? Perimeter as 32 centimeters, right? So let's try to take a rectangle. Given perimeter as 32, but do we have length and breadth? No. So let us take the length as L and breadth as B. And we know the perimeter formula is 2 times of L plus B, which is given as 32. 2 times of L plus B, which is given as 32. So from here you can see that L plus B, length plus breadth, will be 32 by 2, which is equal to 16. Length plus breadth is equal to 16. So we need to make all the integral means all the integers, all the numbers, right? You cannot have a side like 1.5, like 1.2, 1.9. No, it should be 1 or 2 in that say, right? So as we have the relation L plus B equal to 16, I can take length as 15 and breadth as 1 centimeter. Yes, we can take like that. Okay, 14 and 2, 13 and 3, 12 and 4. Okay, so 4 possibilities, 12 and 4, and then we have 11 and 5. So next it is 10 and 6, 9 and 7, 8 and 8. So that's it. We cannot have furthermore. You can extend this one to 7 and 9, but 7 and 9 we have already discussed this one, 7 and 9. Right? 6 and 10, 5 and 11, 1 and 15, 2 and 14, 3 and 13, 4 and 12. All these are the same shapes, right? All these are the same figure. Length and breadth. Correct? If length is 9 and if you are trying to make the breadth as 9, no, that will again become length. Okay. So L plus B equals 16. So the possibilities are length is 15, breadth is 1, 14, 2, 13, 3, 12, 4, 11, 5, 10, 6, 9, 7 and 8, 8. So this is where we get the length and breadth when the perimeter is given as 32 centimeters, right? When both length and breadth are equal, we can say if this case is there, this will come for a square. This come for a square, but for the remaining cases, it is a perfect rectangle. Okay, so moving ahead, a square picture frame has sides of 0.75 meters. Okay, a square picture frame has sides of 0.75 meters. If the cost of a colored paper is rupees 20 per meter, what is the cost of putting colored paper around the frame? Once again, let's try to understand. A square picture frame has sides of 0.75 meters, right? So this is square picture, has sides of 0.75 meter. So this is 0.75. This is also 0.75, 0.75 and 0.75. So for this frame, okay, if the cost of a colored paper, so we are tying a colored paper to that for the frame. The colored paper is rupees 20 per meter. The cost of the colored paper is rupees 20 per meter. What is the cost of putting colored paper around the frame? Around the frame means all the four sides. All the four, so the perimeter which we discussed yesterday also, 4 times of A, 4 times of 0.75, where A is the side of the square. Right, so let's try to multiply this one. 75 into 4, 5 4 is 20, 7 4 is 28, 130. So it is a 300 and there are 2 decimal places. So keep it back. So 3.00. So perimeter is 3 meters. And next, what is the cost of putting colored paper around the frame if the paper cost is rupees 20 per meter? So the total cost is, we have 3 meters, 3 into rupees 20 per meter, that will give you 60 per meter, 60 rupees. Right, so the total cost to keep the frame with the colored papers is rupees 60. Is rupees 60, right? Okay, let's move forward for the next question. Find the cost of fencing a square park of side 250 meters at the rate of rupees 12 per meter. Okay, so find the cost of fencing a square park. Once again, we have a square park of side 250 meters. 250 meters park is there. So now tell me, what is the perimeter? We discussed yesterday what is the perimeter of a square. Perimeter of a square is 250 into 4. Perimeter is 250 into 4. Why into 4? Into 4 means all the 4 sides. If it is an equilateral triangle, 3 sides, or equilateral, let's say regular, we say regular pentagon or hexagon, decagon, so you need to multiply with that number of sides. So here 250 into 4, let me multiply what is 25 into 4. 5 4 is 20, 4 is 8, 9, 10. So perimeter is equal to 100 and this 1 will come here. So that becomes 1000. What is that? Perimeter is 1000 meters. Now the total rate is rupees 12 per meter. So rupees 12 into 1000 meters. Rupees 12 into 1000 meters, that will give you 12,000. That will give you 12,000 rupees. Okay. So the total rate is 12,000 rupees. Find the cost of fencing a square park of side 250 meters at the rate of rupees 12 per meter. Rupees 12 per meter, 12 into 1000 meters is the perimeter, so we get 12,000. Right? A simple, very straightforward question. Let's try to understand one more. Find the side of the equilateral triangle whose perimeter is 54 centimeters. Equilateral, what do you mean by equilateral? Equilateral states that all the sides of triangle are equal. Equilateral states that all the sides of triangle are equal. Okay. For example, if you have a triangle, if this base you take it as x centimeters, even the other 2 sides will be equal to x centimeters. Only then we can say that it is an equilateral triangle. Okay. Find the side of equilateral triangle whose the perimeter. You know that perimeter of the triangle is 3 times of a. So perimeter, which is equal to 3 times of x, which is equal to 54. So from this information, we need to bring what is the x. From x, we need to go back to the remaining things. Okay. So x is equal to 54 by 3. X is equal to 54 by 3. So 54 by 3, 3 and 54. Let's try to divide. 3 1s 3. So 2, 4, 3 8s are 24. 3 8s are 24. So that will give you 18. Okay. So x is equal to 18 centimeters. So what is this 18 centimeters? 18 centimeters is the side of the equilateral triangle whose the perimeter is 54 centimeters. I told you what is the perimeter. It is a sum of all the sides of a given polygon. Polygon means closed figure. Okay. Next one. A piece of wire is 24 centimeters long. The length of each side of the wire is used to form a square, hexagon and octagon. Once again, let's try to understand more about that. A piece of wire 24 centimeters long. 24 centimeters long. The length of each side of the wire, if it is used to form a square. So square, so I told you all the sides are equal. So that becomes 4 times of a. 4 times of a, and what is the side length? Side length, the length of each side of the wire is used to form. The piece of wire is 24 centimeters long. The length of each side of the wire is used to form. Okay. So 4 times of a will give you 24. That means the complete perimeter is equal to 24. So A is equal to 24 by 4, and that becomes 6 units, right? So it is 6 centimeters. So what is the 6 centimeters? The piece of wire is 24 centimeters long. The total is 24 meters. The length of each side is 6 centimeters. 6, 6, 6, and 6. Right? Now let's try to move and see what is the regular hexagon. What do you mean by hexagon? Hexagon is a polygon with 6 sides. Hexagon is a polygon with 6 sides. And what do you mean by regular? Regular means all the sides are equal. Regular means all the sides are equal, right? So now tell me, if all the sides of hexagon, what do you mean by hexagon? Hexagon is a 6-sided polygon. Hexagon is 6-sided polygon, right? So 1, 2, 3, 4, 5, and 6, right? So this is a regular hexagon which has, let me erase that here. 1 second, yeah. Hexagon which has 6 sides and 24 centimeters. So 6 times of A. 6 times of A will give you 24 centimeters. So A equal 24 by 6, which becomes 4 centimeters. So each side of a regular hexagon will be 4 centimeters. Next question, regular octagon. Octagon means 8-sided polygon. 8-sided and all the sides are equal. 8-sided. So 8A is equal to 24. So A is equal to 24 by 8. That will give you 3. A is equal to 24 by 8. That will give you 3, right? So if that 24 centimeters wire is made into square, each side will be 6 centimeters. Hexagon 4 centimeters and octagon 3 centimeters. So as you keep on increasing the sides with the same length of the wire, every side length will change. Okay, the length of each side will decrease from 6 to 4 to 3 and still ahead. Okay, so moving ahead, let's try to understand more about this one. Find the perimeter of following shapes. You can see a beautiful shape here. A beautiful shape here. So 2 centimeters, 4. This is not given, but this is given 4. 2. This is not given 4 again. 2, 4. And this again 4. This is 2. 4 and 4. Right, so this is how all these values are there. So we need to find the perimeter. Perimeter means sum of all the sides. I'm telling you again, perimeter means sum of all the sides. So just add all these sides. 2 plus 4 plus 2 plus 4 plus 2 plus 4 plus 2 plus 4. How much is that? 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 2 is 12. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 2, 22. 22 plus 4. 22 plus 4, 26, right? 26 and 27, 28, 29, 30, 31, 32, 32, 33, 34, 35, 36. Okay, so if you're starting from here, we'll get 36 centimeters. Once again, let's try to understand that. 2 plus 4, 6, 6 plus 4, 10, 10 plus 2, 12, 12 plus 4, 16, 16 plus 4, 20, 22, 26, 28, and 32 plus this 4, 36. So the total perimeter of the given figure is 36 meters or centimeter, whatever it is, 36 centimeters. It was given here in centimeters, so that will give you 36 centimeters. Okay, so what is happening here? When you are trying to find the perimeter, just not one side, we need to add each and every side, each and every boundary. Each and every boundary, right? So starting from here, 2, again I'll end up here, but in the meanwhile, we need to add all this, right? So 2 plus 4, 6, 6 plus 4, 10, 10 plus 2, 12, 12 plus 4, 16, 20, 22, 22, 26, 26, 30, 32, 36, yeah, 32 and 36. Once again, let me calculate that. 2 plus 4, 6, 10, 12, 16, 20, 22, 26, 28, 32 and 36, correct. So the total perimeter of this shape is 36 centimeters. Is 36 centimeters, right? Moving ahead, a flower bed is in the shape of a square. So this is completely a flower bed with a side 3.5 mm, 3.5 meters. Each slide is to be fenced with 4 rows of rope. 4 rows of rope, careful. Find the cost of rope required at rupees 15 per meter. Once again, let's try to understand the question more about. A flower bed is in the shape of a square with side 3.5 meters. So what is the complete perimeter? 3.5 into 4th rhyme, right? Or 3.5 into, let's say it is 4 sides. 3.5 is each side. So what is 35 into 4? 5 4 is 20, 4 is 12, that means 14. Right, so that will give you 1 4, and we have decimal, so keep point here. 14 or 14.0, both are same. Right, so now what happened? That is a perimeter and each cost is given, but each side is to be fenced with 4 times of rope. Okay, so the total cost is equal to 4 times of 14 into per meter cost is 15. Per meter cost is 15. So 4 into 15 is 60. 60 into 14. 4 into 15 is 60. 60 into 14, right? So 60 into 14, let me write, verify 14 into 6. 6 4 is 24. 6 1 6 7 8. That becomes 840. 840 will be your answer. Okay, find the cost of rope required at rupees 15 per meter. You need to pay total rupees 240, rupees 840, rupees 840 to get the work done. Okay, so moving ahead. Bunty goes around a square park of side 80 meters and Bubbly goes around a rectangular park with length 90 meters and breadth 60 meters. If they both take 3 rounds, who covers the more distance and by how much? So covering the distance is nothing but perimeter. So from one part to other part, if you're traveling, so that is a perimeter, right? So Bunty goes around a square park of side 80 meters. Square is here 80 centimeters, and Bubbly goes around rectangular park with length 90 and 60. 90 and 60. If they both take 3 rounds, who cover the more distance and by how much? So we need to take care of 3 rounds. So 80. So let's say starting from here it is 80, and then again 80, 80 and 80. So 80 into 4, which is a 320. 80 into 4, which is a 320. So that is already there with us. Next here. Okay, a length 90 meters and breadth 60 meters. If they both take 3 rounds, so 320 into 3. So 3 into 0 is 0, 3 to 6, 3 is a 9. So that is a 960. Okay, if they both take 3 rounds, who covers the more distance and by how much? That is the 960 meters. What about this 90 plus 60? 2 times of 90 plus 60, the perimeter. So 2 times of 9 plus 6 is 15. 9 plus 6 is 15, so 1500. 9 plus 6 is 15, so 1500 came. No, it is not a multiplication, it's just simple addition, so just keep 10. Just keep 10 or 150. 90 plus 60 will give you 150, right? So that will give you 15 to the 300. So this is for one rotation, right? But total they take 3 rounds. For 3 rounds, 3 into 300, so that becomes a 900 with length 90 meters and breadth 60 meters. If they both take 3 rounds, who covers the more distance by how much? So it is a 960 meters and that is 900 meters and that is 960 meters. So the person going through the square is flexible, I mean to say is preferable, because he is actually it's not preferable, he's actually traveling 60 kilometers more than this figure, right? So this figure is only good. What happened here? 960, here it is 900, so there is a difference. There is a difference of 960 minus 60, so that will give you 900. 960 minus 60, that will give you 900, right? So you can try to do that from there. Let's go for one more question. So now let's try to discuss about area. Okay, although we don't have much time left, we'll try to cover that in the next class. But what is the area? The amount of a surface enclosed. Surface enclosed, it's not the boundary wall we are talking about. The surface enclosed, all these things, right? So this is what they mean by circle enclosed. The amount of surface enclosed by closed figure is called its area. Okay, so this small joke, small thing, that this complete thing is its area, right? Whatever the shaded portion is. So the point is how to find the area of a given figure. How to find the area of the given figure. Let us try to understand one example. Okay, right. So you can see a diagram here. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So all these 12 boxes are perfect. All these 12 boxes are perfect. If more than half a square is in the region, then count it as 1 square unit, but we don't have that option. We have, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the question that we are discussing about? Finding the perimeter as well as area, right? So, right, for perimeter, okay, for area, what do we say? Every box is 1 unit. Every box is 1 unit, but not always every figure comes in the exact graph. Sometimes we may have these type of extra, right, these type of things, so that we need to take care of, because for smaller objects that area will be very, very specific. The same way, okay, it's in the same way we have one more question. If exactly half the square is covered, then what will happen? Right, so count it as a half square unit, count it as a 1/2 square unit. Next one, right, so if less than half a square is in the region, do not consider the region. So less than half, if we have somewhere less than half, maybe something like this, so you just don't try to involve here, right? Just do not consider the region. If less than half a square is in the region, you no need to include that, correct? So from here we can continue in the next class, perimeter and area. We discussed about perimeter and this is all about area. In the next class we are going to discuss more applications based on area, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, so today we'll be learning about water cycle. And when I say water cycle, it is a process that is responsible for rain. So we'll be learning how rain will occur, how rain will fall. Okay, my name is Seshan Reddy, I'm a graduate from IIT NEET. Let's go into the class. So there is a process, as I told, and that process starts from evaporation. It starts from evaporation, right? So in last class we already learned about evaporation and condensation. These two are very important for us. So let's start with evaporation. So what happens in evaporation, everyone? In evaporation, water converts into water vapor. I can say water into water vapor. And can you see water vapor? We can't. We cannot see water vapor. Water vapor is invisible to us. Water we can see. Right? Water is a liquid, whereas water vapor is a gas. This is what happens in the process of evaporation. What about condensation? What about condensation? What happens in condensation, everyone? Evaporation and condensation are important for water cycle, for rain. So in condensation the reverse happens. That means water vapor will convert or will condense into water. So it is the reverse. Water vapor, as we know, is gas. Water is a liquid. So gas to liquid, that is what happens. So two processes, evaporation and condensation. Clear? Good. So now we'll talk about evaporation of water on the earth. And as we know, there is too much of water on earth. Rivers, lakes, seas, oceans, all of them have water. Too much of water. Almost 70% of earth is covered with water. Right? So here look at this. Obviously there is sun. From the sun we get sunlight, and sunlight heats up, warms up the earth. Yes? Right. So let's say on a warm day, when the temperature is high, the sun heats up the ground, okay, but it will also heat up what? The water in seas, oceans, rivers, ponds, lakes, all of them. And when sun heats up the water, what happens? It will lead to evaporation. It will lead to evaporation. So this water converts into water vapor by the process of evaporation. So not all of the water, by the way. Some amount of water will be converted into water vapor. You can see the image here. There is ocean surface, there is sun, it provides the heat, and automatically what happens? Water converts into water vapor. By which process? By the process of evaporation. Clear? Good. Simple enough. Now the question is, where does that water go? Where does that water vapor go? Where does the evaporated water go? Into the air. Okay, simple enough. But after that, where does it go? That's the question. Okay. So what happens is, the evaporated water vapor rises up into the atmosphere as it is lighter than other gases in air. What does this mean? I'll give a simple example. If you take water in a tub, and if there is any air bubble at the bottom, what happens to that air bubble? If there is any air bubble at the bottom, what happens to it? It rises up. Air bubble rises up. Now the question is why? It is because it is light. Light will mean less mass, less heavy. Because it is light. It is not heavy. Its mass or its weight is less. Right? The same thing happens with gases also. Any gas. If it is light, if it is not heavy, it will go up. It will go up. Okay. So here also, let's say this is the ground, or you can say water surface. I mean, we will not take ground. We'll take it as the ocean surface. Ocean surface. Now what's happening? Water vapor evaporated. Yes, evaporation took place. Now the water vapor, what happens is, it is light. It is comparatively light. What are the other gases that are there in the air, which we know? We breathe oxygen. We need oxygen, right? So when we take in air, we make use of oxygen. So there is oxygen. There is carbon dioxide. You might have heard about those names. So there are different gases in air, and water vapor is lighter than those gases. So what happens is, it will go up. So water vapor will rise up. Water vapor goes to higher levels, higher heights. You can say higher level will mean higher height. Okay, it keeps on going. The thing is, as you go up, what happens to temperature? You might have seen this in some movies. That Iron Man movie, Iron Man first part, I think. As that Iron Man goes up, flies up, right? Ice forms on him, ice. What does that mean? It means as you go up, temperature decreases, it becomes cold. So at the top, you have colder air. Comparatively at the top, what do we have? We have colder air. So water vapor is going up. At the top, you have colder air. So water vapor will cool down. Obviously, right? Water vapor is going up. There the temperature is low. There we have colder air. So water vapor cools down. And what happens when water vapor cools down? What happens when water vapor cools down? Condensation takes place. See that here. That's what we have learned. Condensation, it takes place when it is cooled down. Yes or no? Right. So here water vapor will again convert into water. There are many steps that take place. You have to be careful. So water vapor evaporates. Because it is light, it rises up. It goes up to higher levels. There you have colder air. And then what happens? Water vapor converts into water, condenses into water. Okay, we'll look at them one by one. So as water vapor reaches higher levels, will mean higher heights, it cools down. Why does it cool down? It cools down and condenses into water droplets. It will cool down. So when you cool down water vapor, it will convert into water. So it will condense into water droplets. Why? The reason is the air at higher levels is cold. So as you keep going up, as you keep climbing Mount Everest, what happens? Temperature decreases, it becomes cold. That is the reason. Okay? So, okay. So at the top, I mean you have to imagine, very high up. Okay, high up in the air, water vapor converts into water. Now these water droplets will not be big, will be very, very, very small. They will be so small that they can float in air. The water droplets up above will be so small that they can float in air. And how do they float in air? These tiny droplets of water remain floating in air as clouds. So many of us wonder, right, what are clouds? Because clouds can take different shapes. So what are clouds? So clouds contain water, very small water droplets, very, very, very small. Okay? Okay, good. Now clouds, what are clouds? As we know, our clouds form from water in the sky, we just learned. As the water vapor goes up, it cools down, it converts into water, and that water will be in the form of a cloud. And the air where the clouds form, or where the cloud forms, must be cool enough for the water vapor to condense. We learned. As you go up, air will be very cold. And the water will condense around things. I mean, cloud does not only have water, it will also have dust particles, it will also have ice particles, yes. So cloud is made up of all of them, and they'll be very, very, very small. Very small dust particles, very small ice particles, very small water droplets. So cloud contains all of them. Okay, good enough. So these are clouds. So what all did we learn now? We learned about this ocean surface. From ocean, water evaporates, it goes up, and clouds are formed. And clouds are formed. Water vapor condenses into water and clouds are formed. Now, are clouds at rest or clouds move? What happens? Well, obviously, you would have noticed clouds. Look up at the sky and you can see clouds. Are those clouds at rest always, or will they move? Clouds keep moving, yes or no? And how do the clouds move? Who pushes them? Winds pushes, right? Winds push clouds. Winds push clouds. So if this is ocean, if this is ocean surface, any water body, and let's say this is ground, solid ground where we are. So because of wind, the winds, what can they do? They can push the clouds. They can push the clouds, and the clouds, they are dragged along with what? Along with the wind. They are dragged along with the wind. And when the clouds are moving, if they come across much more colder air, you can say cool breeze. Breeze is nothing but wind, cool winds, or colder air. Then what happens? It's more cold. Colder than here. So what will happen in that case? What will happen is more water vapor will convert into water. Right? So here the size of water droplets will increase. I mean, here if the size of water droplets is this, let's say these are water droplets, very small water droplets. When it comes here, the water droplet size will increase. The water droplets size will increase. That means they become heavy. They become heavy. Cool breeze or because of colder air, what happens? Water vapor converts into water vapor. Again, more water vapor converts into water. So droplets increase in size. Droplets increase in size. They become heavy. So droplets, water droplets, their size will keep on increasing. But after some time, after some size, they become very heavy. And if they become heavy, they fall down to the earth. They fall down to the earth, and that's what happens. That's how we get rain. Got it? Okay, good. We'll again explain those things. Don't worry. So all the points are given here. Look at that. First of all, look at the heading. Rain, or else it is given a special name, precipitation. So whenever you look at precipitation, you have to understand that they are referring to rain. They are referring mostly to rain. Okay, so read. We'll go through all the points. We discussed them, but we'll go through them. Due to wind, the clouds formed on water bodies like seas and oceans. Start imagining. We are talking about this step here. Clouds formed on the oceans. Due to wind, they flow. Due to wind, they move towards the land. First step. Then, as the clouds enter colder regions, if it is cold, water vapor present in the air condenses, making the air droplets bigger in size. More water vapor converts into water. There is more water, so size of water droplets increase. Now these clouds, as the size of water droplets increase, they become heavy and appear grey in color. You know, right? Whenever rain occurs, the clouds are grey in color, mostly. Whenever rain occurs, the clouds are grey, mostly. Yes? Good. And again, see this. When the size of water droplets become big enough, what happens automatically? That becomes so big that the clouds cannot hold them anymore. Clouds cannot carry them anymore. They fall down. They fall down as what? They fall down as rain. Okay, so understand the process again. We have taken that here. Water is evaporating. It goes up. It condenses and forms clouds. Clouds are carried by wind. They go into colder region. Water droplets, size of water droplets increases and it falls down as rain. Is that clear? Good. Now, see, water always does not fall down as rain only. At times it also falls down as snow or hailstone, for example. So what happens in that case? What happens is, if it is more cold, okay, compared to that rainfall, if it is colder, much more cold, what happens is, you'll directly get ice. Water vapor into water. Then water will convert into ice. If it is cold enough, water can also convert into ice. So, in very cold conditions, the drops of water turn into crystals of ice. They freeze into ice. And they fall down. Right? And they fall down. So, when the size of the ice crystals is small, we call it as snow. But when the size of ice crystals is big, see that? Sometimes big drops of water solidify, freeze into ice. So if you have bigger particles of ice and they fall, then we call them as hailstones. Fall as pieces of ice. So bigger pieces of ice, we call them as hailstones. Small ice crystals, snow. Bigger, hailstones. Clear? Good. So now we understood how clouds are formed and how rain occurs. We understood both of them. Good. Okay. So, and now, here if only this happens, understand this. If only this was happening, this is ground and let's say this is ocean. So from the ocean, water is going away, escaping. Clouds are formed. Clouds come here. Rain occurs. Now, if only this process is happening, then how come water in ocean is not decreasing? Water is escaping from ocean, yes or no? And it is raining on the ground. So ground is getting water. Ocean is losing water. Then how come the amount of water or the water level in ocean is not decreasing? Why is it not decreasing? Because water from the ground eventually comes into ocean. Water from the ground comes into ocean again. How? Simplest and the best example is rivers. Think of any river and look into a map. Okay, look into a map. Where do the rivers end? Where do the rivers end? And you will be surprised to notice that most of the rivers, even in India or across the world, most of the rivers go and end where? End in the seas or oceans. End in the seas or oceans. So, the water received by the ground, by the land, from rain, eventually reaches rivers. Okay, rain is falling on the ground. So what happens to that water? Okay, that water, we call them as streams, very thin rivers. You can think of them as very thin rivers. Through streams or underground drainage, they reach what? They reach rivers. And most of the rivers flow into seas or oceans. So the water, through the water cycle, through rain that enters or that reaches ground, it will again go into the sea or ocean. Thus, the water that evaporates from ocean eventually reaches ocean again. Ocean again. So it is a cycle. It starts from ocean, it again comes back to ocean. So it's what? It is a cycle. It is a cycle. Is that clear? Good. And that itself we call it as water cycle. This complete process we call it as water cycle. You can look at the steps, all the steps that we discussed. First one, evaporation. Then condensation into clouds. Then condensation into clouds and the movement of clouds because of wind. And then precipitation. And then what? Precipitation, or you can say rain. That's it, simple process. Got it? Good. I'll go into that point again. But before that, let's look into a small video. Okay. Just a minute. I'll switch off the audio. I'll explain the things. So look at it. So first, from the ocean or from the sea, evaporation occurs. They will show it. It will be shown. See here. From the sun, the ocean is receiving heat and the water vapor evaporates. Right? Water vapor evaporates and it rises up. It rises up. Yes. And see, gradually or slowly, clouds also will be formed. Just wait a minute, it will be shown. Okay, so here the water is evaporating. When it goes up, water vapor converts into what? Converts into water droplets because of condensation. Because of condensation. Yes, and those water droplets come together and form a cloud. And they form a cloud. So clouds are formed. And again, as the clouds become huge, right, as the temperature becomes cold enough, this size of water molecules is increasing. See that? The size of water droplets is increasing. The size of water is increasing. They become heavy and they fall down. They become heavy and they fall down. And when they fall down as rain mostly, or in terms of snow, hailstones, anything. See here, it's raining. And here you can see that from the rivers, just a minute. Sorry.
Let's look at the science of rain and how raindrops fall. First, we'll need the sun.
Just a minute, I'll play it to you. We'll continue from there. The size of the water droplets is increasing, and as the size of water droplets increase, those fall down. And here look at the river. From the river, water is again entering what? River is flowing and it's again entering the ocean. So it's a cyclic process. It's a cyclic process. See that? It's a cycle. It repeats. Evaporation, clouds, rain, and again from the river, it goes into ocean. Understood? Good. So this is a water cycle, right? The same water cycle, the same one I am showing it to you. The same process. Okay? We discussed all of them. You might have understood all of them. Good. So, now again, obviously, humans are bad. Because the things that we do for ourselves ultimately end up destroying nature. They end up what? They end up destroying nature. So, we damage nature. And currently, one of the most dangerous consequence is what? Is global warming. Something called as global warming. What is global warming? Global will mean globe, throughout the earth. So throughout the earth it is warming up. Warming will mean heating, right? So global warming will mean the complete earth is heating up. It is becoming hotter. Its temperatures are increasing. Why? Because of some activities, many activities by the way. One of them is deforestation and the other is pollution from factories. Not only factories, pollution from vehicles also. Right, so deforestation and pollution are some of the major causes, and because of them, what's happening? The temperatures are increasing. Earth is becoming hotter. Earth is becoming hotter. Now the issue with this is, if earth becomes hotter, then the colder airs will decrease, the colder temperatures will decrease. Then how will the water vapor condense into water? Or how will rain appear? Because as we have learnt, condensation should take place. Condensation should take place for what? For rain. And for condensation we need colder temperatures. But global warming is increasing the temperature. Global warming is making the earth hotter. It's making the earth hotter, so condensation becomes difficult. Condensation becomes difficult. So that is the reason the atmospheric conditions are not favorable for clouds to get cooled. For clouds to get cooled, and consequently there is a decrease in rainfall. There is a decrease in rainfall. And this disturbs the water cycle obviously. This disturbs the water cycle and it can lead to floods as well as droughts. To floods as well as droughts. So we have to be very careful with it. So you have to be careful about the activities you do, basically about the pollution. Okay? Good. So we learned about water cycle and we learned about some activities that disturb the water cycle also. That is nothing but global warming. Good? Okay. Now there is one more topic that we have to learn about, that is monsoons. What is monsoon? Monsoon is basically a wind, okay, just a wind. A wind that brings rainfall to India. Monsoon is what? Monsoon is a wind that brings rainfall to India, and it's not a small wind, okay, it's on a huge scale, on a large scale. Look at this. So we get rains in some particular months during the year, obviously. When do we get rain? When is the rainy season? Mostly throughout the India. For most of the India, the rainy season is from June to September, mostly. So during these months, June, July, August and September, we get most of the rainfall. We get most of the rainfall. Why is that? This is because during these months, from June to September, there are winds called as southwest monsoons. Their name is what? Southwest monsoons. That they flow over India. And they give us rainfall. Okay. The sentence will continue in the next one. So that's not there. Got it? So southwest monsoons, they flow over India. And why do we call them as southwest? Very simple reason. Look at the winds here. Look at the winds. Where are they coming from? They are coming from here, this direction. And this is southwest. Why southwest? Because if I draw it in this way, this is west, this is south. So this direction will be southwest. What do we call it? Southwest. So the winds are coming in this way from this direction. So we call them as what? We call them as southwest monsoon. Southwest monsoon. Clear? Simple. So all that you have to understand is we get rain, or most of the India gets rain during June to September. Because of which winds? Because of southwest monsoons. And where do they flow from? They flow from Arabian Sea in or from the southwest direction. From the southwest direction. Good? Okay. Now similarly we have northeast monsoons also. Now because of these northeast monsoons, not all of India receives rain, only a few parts, particularly Kerala and Tamil Nadu. So some parts of India, particularly Kerala and Tamil Nadu, also receive rain during the months of November and December. That is not rainy season for most of India, right? So why they receive rainfall in November and December? That is because of another type of winds called as northeast monsoons. Northeast monsoon will mean it is coming from northeast. What is northeast? This is north. This is east. So they will be coming from this direction, northeast. Got it? Good. So that's it, everyone. We learned about rain, we learned about water cycle, and we also learned about monsoons that bring us rain. Okay, so thank you. Thanks a lot.